Good morning, everyone. Welcome to today's presentation. I'm excited to introduce our topic, the Briquette mixer unit. Today, we'll explore how this innovative equipment works, its benefits, and how it can improve your processes. We'll cover the key features, the operational workflow, and some real-world applications. So, let's dive in and discover what makes this unit so valuable. Let's take a moment to go over the overview. In this slide, I want to highlight the key points that will guide us through the rest of this presentation. We'll start by discussing the main concepts that are essential to understanding the topic. Then, I'll connect these ideas to the overall theme, so you can see how everything fits together. The goal here is to set a clear foundation so that as we move forward, you'll have a solid grasp of what's most important. This overview will serve as a roadmap, helping you follow along and understand how each part contributes to the bigger picture. Now, let's take a look at how the pre-weighted material is fed into the mixer. It starts with the material being placed into the hopper, which acts as a storage and feeding point. From there, the material moves onto the conveyor, which efficiently transports it to the mixer. This process flow is crucial because it ensures a steady and accurate supply of materials, maintaining the consistency necessary for high-quality mixing. By understanding this flow, we see how each component plays a vital role in the overall process, helping us achieve optimal mixing efficiency and product quality. After the mixing process is complete, the next step is delivering the mixture to the even feeder using a conveyor. This part of the process is crucial because it ensures a smooth and continuous flow of material. The conveyor system helps us maintain efficiency and consistency, preventing any delays or disruptions. By moving the mixture evenly to the feeder, we set the stage for the next phase of production, which relies on precise and reliable delivery. This step ties into the overall workflow by maintaining a steady pace and quality control throughout the process. Materials can be fed into the system in two main ways, manually or automatically. This flexibility allows us to choose the method that best suits our workflow or the specific requirements of the task at hand. When using manual feeding, it gives us direct control over the input, which is useful for small batches or when precision is needed. On the other hand, automatic mode streamlines the process, making it more efficient for larger volumes or repetitive tasks. Now, let's look at the process flow. The key point here is that, regardless of how materials are fed in manual or auto, the overall process remains consistent. The system is designed to handle both methods smoothly, ensuring seamless operation. This integration is crucial because it highlights the system's versatility and adaptability, which are essential themes in our overall presentation. So, whether you're feeding materials manually or automatically, the process flow is streamlined and efficient, keeping productivity high and minimizing downtime. This dual feeding capability truly enhances the flexibility and robustness of the system, making it suitable for a variety of operational scenarios. Now, let's take a look at the quality sample checking arrangement. This slide highlights the key points we need to focus on to ensure our samples meet the required standards. First, we have the sample checkpoint, which is essentially the critical stage where we verify the quality of our samples. It's important to understand that this isn't just a one-time check. It's a systematic process integrated into our workflow to catch issues early. By establishing clear checkpoints, we can maintain consistent quality and avoid costly rework later on. These checkpoints serve as control points where we assess whether the sample complies with specifications and quality expectations. Remember, the goal here is to ensure that every sample passing through these checkpoints aligns with our overall quality standards, reinforcing the integrity of the entire process. This arrangement is vital because it helps us identify potential problems early, saving time and resources, and ultimately leading to a better final product. So, always pay close attention at these checkpoints to uphold the quality we strive for. Now, let's take a closer look at the mix design. As you can see, we're working with two key raw materials here, coal dust and starch. The coal dust amount is 1,000 kilograms, which forms the main component of our mix. The starch, on the other hand, is at 70 kilograms, serving as a binder or adhesive to help hold everything together. The proportions are critical because they influence the final properties of the product, such as strength and combustion efficiency. Ensuring the correct balance between these materials helps us achieve optimal performance. This mix design is a fundamental part of our overall process, as it directly impacts the quality and consistency of the end product. So, understanding these raw material quantities and their roles is essential for maintaining our standards and improving our processes. Homogeneous mixing, or sometimes called uniform mixing, is a concept that plays a crucial role in understanding how substances disperse in a given environment. When we say that mixing is homogeneous, we mean that the components are evenly distributed throughout the entire mixture. This uniformity is important because it ensures that the properties or concentrations of substances are the same everywhere within the mixture. In many practical situations, achieving homogeneous mixing helps in improving efficiency and consistency, whether we're talking about chemical reactions, environmental modeling, or even pollution dispersion. It simplifies the analysis because we can assume that every part of the system behaves similarly, making predictions and calculations more straightforward. Connecting this to our overall theme, understanding whether a mixing process is homogeneous or not helps in designing better systems and in interpreting data accurately. It's a fundamental concept that underpins many of the models and methods we use in environmental science and engineering. Let's take a closer look at the final product. Here, we see how all the elements we've discussed come together. This is the culmination of our efforts, showcasing the key features and improvements. The goal was to create something not only functional, but also user-friendly and visually appealing. Throughout this process, we focused on integrating feedback, refining our design, and ensuring it aligns with our overall objectives. This final version represents the dedication and teamwork involved, and it sets the stage for future developments. Ultimately, it embodies the core concepts we've explored: innovation, quality, and purpose. Thank you for your attention. As we wrap up, I want to highlight the final product of our process, which is the briquette, ready for use. The key part of this process is the mixing stage, where the materials are thoroughly combined to ensure consistency and quality. We start with the even feeder, which supplies the raw materials smoothly and uniformly. Then, these materials are directed to the briquette extrusion unit, where they are shaped into the desired form. Once extruded, the briquettes are conveyed directly to the mixer, ensuring a seamless flow. Material loading into the hopper is a crucial step, as it sets the stage for the entire process, maintaining efficiency and preventing interruptions. This process flow diagram illustrates how each component works together, creating a streamlined operation from raw material input to finished briquettes. Overall, this system is designed to optimize productivity and produce a high-quality final product. Thank you again for your interest and engagement.